The Kawasaki OH-1 is noteworthy as the first helicopter entirely produced in Japan. It also appears to be the last of its kind in this country. The story of this rotorcraft began with high hopes but has taken an unexpected turn. As the weapon detective, we're now investigating the OH-1 and explore the rise and fall of the flying ninja. The OH-1 is a highly unique observation helicopter with its design, capabilities, and armament. Many recognize it by its nickname Ninja, however, the Japan Ground Self-Defense Forces, or JGSDF, also refer to it by its call sign Omega. Kawasaki produced significantly fewer OH-1s than initially planned, and Japan has already decided to replace the helicopter with a new unmanned aerial vehicle, or UAV. So, what went wrong? In the late 1980s, the JGSDF began studying a new observation helicopter to replace its OH-60Js. The goal was to have a high-performance, maneuverable helicopter capable of coordinating anti-tank operations on the battlefield and defending against enemy units. Initially, the JGSDF considered acquiring US and European models, but ultimately decided that none of those options met its requirements. Therefore, Japan launched the OH-X program in 1991 to develop a new light observation helicopter domestically. The program was carried out in a strict secrecy to avoid political pressure from the USA and accusations of a resurgence of Japanese militarism. Three local companies submitted multiple proposals. Fuji had carried out the licensed production of the AH-1 Cobra and UH-1H Huey, Mitsubishi the S-61 Sea King and SH-60 Seahawk, and Kawasaki the OH-6 Cayuse. The last one had also developed the BK-117 jointly with the German MBB company in the 1980s. On September 18, 1992, Tokyo announced that Kawasaki would serve as the prime contractor with a 60% work share. It was responsible for developing the forward fuselage, dynamic system, final assembly, and initial flight testing. Mitsubishi and Fuji each accounted for 20% of the total work. A month later, the planning phase began. The JGSDF initially considered the no-tower design for the helicopter, but Kawasaki representatives stated that it is inferior to a fenestron tail rotor in terms of energy efficiency. Fortunately, Aerospatiale's patent rights on the fenestron design had just expired. The Japanese initially contemplated equipping the helicopter with the Lichtech T-800 or Turbomika TM333 engines. However, Tokyo rejected them, apparently mainly for political reasons. Consequently, the Mitsubishi's TS-1 M10 turboshaft was chosen. Developed with participation from Ishikawajima Harima and Kawasaki, this engine was based on the Mitsubishi MG5, which was first fitted on the experimental RP-1 helicopter. The new rotorcraft's avionics and primary sensors were also developed domestically. The first OH-1 prototype made its maiden flight on August 6, 1996. Later, 3 more prototypes were built and all 4 machines were delivered to the Japanese Defense Agency for service testing in 1997. After trials, the new helicopter, now called OH-1, was officially introduced into serial production in 1998 and introduced into service in 2000. It was a notable achievement that the development of the first domestically built helicopter was completed on schedule as initially planned without any accidents. The JGSDF's initial plan was to replace all 310 units of OH-6 by March 1995 with an equal number of OH-1s. However, with the end of the Cold War, security concerns shifted and Tokyo aimed to reduce defense spending. Therefore, the number was reduced to 185. Nevertheless, the JGSDF could not reach this figure, let alone get close. By 2013, when serial production ended, Kawasaki had built only 34 OH-1s and converted 4 prototypes to production standards for the JGSDF. During that period, the Japanese constitution prohibited the export of military equipment. Additionally, the OH-1 was primarily designed to meet the JGSDF's specific requirements, making it unsuitable for other countries. As a result, it never had a chance in the international market. Ultimately, Japan built only 38 Ninjas. The JGSDF continued operating OH-6 until 2020. Nearly 40% of the OH-1, including the main rotor blades, is made of composite materials. Thanks to the tandem seating arrangement, the fuselage width is no more than 1 meter and the observer behind has excellent visibility. It features two multifunctional liquid crystal displays, helmet-mounted displays, and armored seats for each crew member. Canopies are also bulletproof. The OH-1 is operated using hands-on throttle and stick controls and features an automatic pilot system with flight holding capability. Developed by Kawasaki, the rigid hub of the main rotor enhances maneuverability at low altitudes. The 4-blade elastomeric main rotor is bearingless and can withstand rounds up to 20 mm. Its successful design earned the Howard Hughes Award for Outstanding Vertical Flight Technology from AHS International in 1998, the first such award for a project outside the USA. The rotorcraft is powered by two TS1 M10 turboshaft engines, which are equipped with a digital diagnostic system and inlet particulate filters. These engines feature full authority digital engine controls. On February 17, 2015, during an emergency maneuver training, one of the two engines on an OH-1 failed and the other was idled. The helicopter had to make an emergency landing at sea, where it subsequently sank. The investigation revealed that the turboshaft blades and discs contacted at high temperatures and pressures, leading to fatigue failure of the turbine blades. Additionally, the crew had been unable to restore engine power from idle. As a result, Japan overhauled the TS1 M10s and improved emergency response capabilities. The engine modifications involved cutting and reshaping the high-pressure turbine blades to create more space between them and reducing the number of high-pressure turbine nozzles to lower vibration and stress. The works continued until March 1, 2019, during which the JGSDF grounded all helicopters. Mitsubishi also developed the upgraded TS1 M10A variant of the engine, which outputs 990 horsepower. Additionally, it offered improved durability and fuel economy, however Japan has not preferred this engine. The transmission can run dry for 30 minutes and the hydraulic systems are redundant for safety. The helicopter is also equipped with an active vibration damping system. The 8-bladed asymmetric fenestron tail rotor reduces vibration and noise, and its hydraulic systems are redundant for safety. With exceptional maneuverability, the OH-1 can perform loops and rolls. Its hydro-stabilized roof-mounted electro-optical sensor turret includes a forward-looking infrared sensor, a laser rangefinder, and a color TV camera. It provides a 110-degree azimuth and a 40-degree elevation field of view. Its position, mounted above the cockpit, allows the Ninja to observe while remaining hidden in the shade of trees or other areas where the enemy cannot see the helicopter. The Ninja has several odd drawbacks for an observation helicopter designed to fly over the battlefield and coordinate anti-tank operations. Firstly, OH-1 cannot transmit real-time information except via voice communication over its radios. Consequently, the headquarters staff can only review visual data collected during a mission after the rotorcraft returns to base, and the attack helicopters, which are supposed to be coordinated by OH-1, cannot receive them either. The OH-1 has 4 hardpoints, 2 under each stub wing, with a total payload capacity of just 132 kilograms, which is surprisingly low for a so-called flying war machine. Each outer pylon can carry 2 Type 91 missiles, the air-to-air variant of the manpads of the same name. The Type 91 has a range of 5 km and a maximum speed of Mach 1.9. Its guidance system includes an infrared sensor and a visible light camera. The inner pylons can carry external fuel tanks, extending the endurance to 1 hour. However, although some sources claim that the Ninja can be armed with rocket and gun pods, such armament has never been seen on the helicopter. So, the OH-1 cannot fight back against the enemy ground units that attack it, rendering the rotorcraft critically vulnerable to such threats. The sole meaningful defense on the Ninja is the locally developed spine-mounted infrared jammer, which is based on the AN ALQ-144 of BAE Systems. Additionally, due to its limited armament, the OH-1 cannot conduct opportunity attacks even when it detects a highly critical target. The twin-seat OH-1 has a length of 13.4 meters, a rotor diameter of 11.6 meters and a height of 3.8 meters. The helicopter's empty and maximum takeoff weights are 2,450 and 8,000 kilograms respectively. Two 890 horsepower Mitsubishi TS1 M10 turboshaft engines provide a top speed of 283 kilometers per hour. Its cruising speed is 220 kilometers per hour and its range is 720 kilometers. The OH-1's combat radius is 200 kilometers. The helicopter can climb to an altitude of 4,880 meters, equivalent to 16,010 feet. During the 1990s, Kawasaki proposed a derivative of the OH-1 with more powerful engines and anti-tank weaponry, known as the AH-2, in response to the JGSDF's requirement for a replacement of the AH-1 Cobra. However, Japan ultimately chose the AH-64 Apache instead. In 2005, as a part of the UH-X program, Kawasaki also proposed developing a utility derivative of the OH-1 to replace the JGSDF's aging UH-1Js. Once again, Japan opted for a US helicopter and manufactured the Bell 412 under license. Kawasaki's other proposal was the OH-1 Kai, which is capable of onboard information analysis, operational planning, situational awareness, and real-time data link. However, Tokyo rejected it as well. Compared to other locally developed military hardware, the OH-1 was not so expensive to cause Japan to cease the serial production after just 38 units. Nevertheless, the helicopter was too costly to replace all of the over 300 OH-6, especially after the First Cold War ended. In the New World, replacing the Kaiuses was no longer an urgency. The massive Soviet amphibious and airborne forces no longer threatened Japan with invasion. A large portion of the remaining aircraft and ships inherited from the USSR had already been decommissioned or rendered useless. The Japan Air and Maritime Self-Defense Forces were sufficient to counter what Russia had. The Japanese Treasury, which had struggled through the recession since the 1973 petrol crisis, used the elimination of the Soviet threat as an excuse to cut the budget for the local helicopter development program. Additionally, the new helicopter had no marketing chance. Washington was displeased with those efforts, and Japan could not jeopardize its relations with the USA further. Also, as previously stated, the OH-1 had an unusually low combat capability. It was not a multi-mission helicopter, which meant it was not cost-effective despite its relatively low price. The OH-6 still maintained sufficient operational efficiency. In summary, Japan did not really need the OH-1, and such an endeavor was detrimental to business, the budget, and policy. In December 2022, Japan announced that it would replace 33 OH-1, 12 AH-64D, and 47 AH-1S helicopters, as well as 26 U-125A aircraft with UAVs. As our viewers know, we believe that flying robots will play crucial roles in the future, but we do not see them as the ultimate solution or game changer on the battlefield. Nevertheless, as an island nation, Japan has a geographic advantage that allows for more efficient UAV operations. Since any invasion force has to come from the sea, the real defenders of this country are the Navy and the Air Force. If they fail and the enemy manages to land in Japan, the invading forces would initially need to regroup in confined beachheads, creating an ideal hunting ground for kamikaze drones and armed UAVs. So, unlike our previous videos, this time we do not present an opposing view of this revolutionary decision. The OH-1 was born in an inhospitable environment. Looking back today, we can confidently say that it had no chance from the beginning. Nevertheless, under these unfavorable conditions, Japan did its best and produced an impressive helicopter. Thanks for watching our video. And please don't forget to subscribe to our channel and click the bell button to be notified of our new videos. Also, you can now click the join button to support our channel. And as always, we would greatly appreciate all of your likes, comments, and shares.